As promised, these are some examples from the homework. On page 693, the directions for problems 23 through 26, it says to find the absolute maximum and absolute minimum of each function on the given interval. If you'll notice, I did say the word and, so I'm looking for both of them. And I can only have those on a closed interval. So first thing I need to do is go find my derivative. Click on my box. Come on, box. The derivative of this should be 1 times negative 1 times e to the negative x. Or simplified down to negative e to the negative x. We then went and we would graph that. So let me go to my y equals. I've already got it in, my derivative. I'll ask it to graph. Now I am concerned between negative 1 and 1. That's my closed interval. I do not look outside that. So if I had to go do my sign chart, notice I have no zeros here at all. Not with respect to my derivative. It does indicate that my derivative is totally underneath the x-axis, and that's where the minus comes from, which means the original curve is decreasing the whole time. So when I have a closed interval, I have to look at the left endpoint, right endpoint, and any f prime equals 0 in the middle, any critical numbers, and I don't have them on this one. So the next part I need to do is I will do a sign chart. Not a sign chart, a t-table. So I've got my left endpoint, my right endpoint. Since there are no critical numbers in here, I do not have to account for that. Notice I've got f of x because I need to find out what my absolute max and absolute min is, and I've got to go back to my original to find those y values. So for this particular problem, this is my largest y value, that 2.718 at that x, and this is the smallest y value. So what I would indicate on my paper, that this is my absolute max, and this is my absolute min. And remember, that's referring to my y values. Now, let's look at the next one. And also you can go verify this. Let me go back to y equals. Let me delete that sign. Let me change my window just a minute from negative 1 to 1. I'm putting in this interval, and I want to see if at my x value of negative 1, that is the largest y value. Let me ask it to graph. So this is the closed interval I have to account for. So this is the largest y value on that interval, and this is the smallest. Alright, let's look at the next problem. I'll move it up some. F of x equals x squared minus 6x plus 7 on the interval 0 to 10. Go get my derivative, which would be f prime of x equals 2x minus 6. And if we graph that, go clear, you should notice if I set that equal to 0, I should come up with an x value of 3. We'll see if this works in my calculator. You can go do your 0 if you want, but that is 3. So if I do my sign chart, come on, computer. See if you agree. At the x value of 3, my f prime is negative before that, it's 0 at 3, and it's positive afterwards. Since 3 is in this closed interval, I have to account for it. So let me move my box over a little bit. So I start with left interval. Any critical numbers that are in between, I end with my right interval. I take these back to the original. And if you do that, you should come up with this information. So now looking at this, the smallest y value I see in this list is a negative 2. The largest is 47. So this should be my absolute min. 47 should be my absolute max. So let me go do my y equals x squared minus 6x plus 7. I need to change my window. I'm going to do it from 0. I always like to put these x values in. I'm going to have to go up to at least 50 to capture that 47. I'll do 50 and I'll go by 5. So let's see if it bottoms out at an x value of 3, but this is my largest value. We'll go find out. So if I look at this graph, I can tell that this is my lowest value here, and this is my highest value, which is what the absolute is referring to. Okay, look, I've got 2 more problems. 35. Let me turn the page. I got to see the directions. 35, it says to find the absolute max and min if either exist for each function. So this is my original problem, and I had to rewrite it. So I go and get my derivative. That would be 1 minus 16x to the negative 2, and go graph that. So 1 minus 16x to the negative 2. I messed up my window totally from the last one, so a zoom 6 will recenter. Remember, this is my derivative, and I have 2 zeros. I do have 2 zeros. So let's get this out of the way and see if you agree with it. If you go find your 0 here, that should be negative 4. Notice I have a break here. It's not defined. That's a partition. So if it's not defined in the original, it's not going to be defined in the derivative. So I've got to have it in there since there is an actual physical break. And 4 is my other 0. So let me see, it's above. It hits at negative 4, then it goes below. So there's my plus, my 0, and my minus. On this one, it is below. It hits. That would be my 0, and then it's above. So if we did it the old way, this curve is going up, topping, coming down, and I did go put this negative 4 back into the original, and I came up with a max of negative 8, and the negative means it's coming down, bottoming, going up. And if you put 4 back in, you come up with a minimum of 8. But now there's a slight issue with this problem. Go back here, I want to type in the original, because you have to understand by definition what it means to be the absolute max and absolute min. Change my window just a minute. I'm going to make my Y's a little bit bigger so you can see the actual picture better. Went too far. Go up, please. By definition, what absolute max is, it is the largest Y value on the whole entire graph. The problem with this one is, here's my absolute max, but it's just on this section of the curve. This is a min, but it's not an absolute. That is a minimum value of 8, but if you'll notice, there are smaller Y values. So for this particular problem, and because of the graph, and I'm not given any interval that I have to account for, I do not have any absolute max or min. There are no absolute extrema. By definition, the absolute max is the largest Y value on the whole graph, and absolute min is the smallest Y value on the whole graph. So even though this is a relative, that's what it's called, a relative min, that's just because in this area, it is not an absolute because there are smaller ones. Now the next problem is sort of similar to this one, but I am given an interval I've got to play with. They want us to find the absolute maximum value on the interval 0 to infinity for the following problem. So if you'll notice, it does look a little bit similar, and I rewrote it. So my derivative would be negative 3 plus 12x to the negative 2. Oh, it's so slow. And if I go graph that, negative 3 plus 12x to the negative 2. I'm going to look from 0. I am restricting myself here. So let me do 0. Well, let me put negative 10. Why not? Well, brother. So you'll see what I'm talking about. So it's taken on the shape similar to that other one. Get this box out of the way and see if you agree with this. So there's my negative, my 0, and it is above. So I've got this. But now this is where this interval comes in. Can I insert something here? You do not look at this section, because I'm only supposed to go from 0 to infinity. So I'm stopping here. So I don't look here. So if that's the case, and I only can look at this part, then I do have a maximum. And it looks like it's an absolute max. So let me go to y equals, graph the original, but I am going to restrict my window because I want to see if this is in fact the case, because I am given this restriction here. So let me ask it to graph. So if I'm just going from 0 to infinity, this is the largest y value. I wish that would go away. That's the largest y value that I have on that interval. So I do have an absolute max here of 8, and it occurs at x equals 2. So hopefully these problems will work, and I'll talk to you later. Bye-bye.